Exams were good. Okay, score. You have your corrections due if you like. So thinking maybe if we can do, because we have break. I won't see you guys for a long time after Wednesday. I'm going to do this here. So your test corrections are actually due on Wednesday. Are we good? Or what happens after that, then we have no clue that you even took a test. That's the problem. So corrections. Okay. Bring this down because I don't like the way it looks. There it is. Okay, is that better? That way. We have no school on Friday?
No,
Just elective classes. Yeah, just elective classes.
Oh my gosh, I forgot about
So-
Wait, so are we gonna go over the test?
We are going to go over the test on Wednesday. I'm going to try to as much. We have it. It's a little bit of compact here. So I'm going to do 7.3 today, hopefully, as much stuff to get you guys started. 7.4 definitely is a test review and 7.4. On Wednesday, I'm going to have to give you a video of 7.5. So
I thought we weren't doing 7.5.
we're skipping 7.6. Skipping 7.6, we're doing 7.5. Then I see you guys a week later, which will just do any questions from chapter 7 anywhere. Then I found out that there's no, there's elective classes or there's no school on the 18th. Is that true? Okay, so presentations got moved up over here. And we'll just do the first 3 sections of chapter 8. Okay, schedule-wise, are we okay?
Yes.
Kind of pushing at the end here.
So
Go
when
ahead.
are we gonna do like homework questions? 'Cause I'm not seeing
Yeah.
them.
Sorry, guys, that's true. Dun, 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 dun.
Yeah, I feel like it's that.
That's the fun part.
I guess, well, okay, I don't know about everyone else, but the homework questions I have for 7.2 and kind of 7.1. For 7.1, it was the one with like the northeast thing. And then for 7.2, it was all of the problems that had 2 solutions. I don't know if I just forgot how to do those when we did those in class, but I looked at them and then I looked over my notes and I couldn't figure out how to do it.
All right. You guys talk to me. Is it possible for me to give you guys homework solutions by video?
Yes.
Or by a scan of, I can do one of 2 ways here. I finally got the student solution manual to the textbook. So I could give you the scan, the question or answer to it, right? The worked out answer, or I could do a video of that.
For me,
Or is it just classes class?
yeah, because then we
Class
can
is
like
class.
ask questions
Uh-huh.
like while you're going.
Gotcha. Okay, that makes sense. Okay, then let's do that here. Let's go through as much as we can together. If we'll get to, however we get to chapter 8, we'll get to chapter 8. However many sections we get to. But I'd rather have you guys understand the material as we're going forward than me lecturing and then you guys have no clue. Okay, so let's do that. Let's jump back to 7.2 today. Let's handle any homework questions. We'll do that.
Wait, from 7.1.
Or 7.1, yeah, sorry. 7.1 homework questions, 7.2 homework questions, if you guys have them. And 7.1 is due today, I believe. Is that right?
Yes.
Okay, so let's do that. However we get through chapter 8 is cool. Okay, let's jam with this. And well, that broke my plans.
Sorry.
No, just kidding. I'd rather you guys have it with you eat through it here. Okay, I'm still recording. We're good. Let's go with any questions from 7.1. Give me numbers.
21, 29. What was the vector, or what was one you were saying?
Oh,
The
33.
navigation.
Yeah,
33
and 37.
and 37. Okay, perfect. 7.2.
I had all of the ones that were the two solutions. So if we could just go over like one problem with the two solutions,
Sure.
that would be fine, and then I could work through that.
Okay, give me that problem then.
Okay, how about just 7?
7, okay. Awesome.
Thing.
Okay, and if it's not, then just,
Was that one with 2? Or was that just, oh. I know 1 with 2 was definitely 20. The ones I have are 7, 11, and 21, so any one of those.
bless you. Okay. 7.1, which is due today. Let's go with it here. This is the figure. Okay, it's this one right here, right? It's the one that has the little triangle like this and then the circle that goes along with it. True, false, what do you guys say? Thank you.
I'm very impressed.
So A is equal to, where's my ABC here? All right, redrawn and let's go. A is 31 degrees. S is the arc length, which is 11. And R is 12. That's cool. And find X. So how do we find X right there? Good morning to you. Come on in. Degrees, 31 degrees. We are doing homework questions from 7.1. If you want to add to the list, go for it. Let's go with it here. So that's 12. So that means this is 12 as well. Correct? Think so. We're going to cover something like that on the notes here. Okay. So this whole side, that would actually be X plus 12, right? To get to that piece, to get us to X. All right, the only thing I'm thinking about is for the law of sines, to find sides, right? We need a angle on its opposite side, angle on opposite side. And so thinking maybe I can find the center right here. Is there a way? Do we know any formula that helps us to find the center right there?
Is it that the interior angle theta equals S over R?
Something like that, yeah. Or the arc length formula. Do you guys remember that from a while back? It was something that looked like that. And that was a little bit of the trick to the problems, especially that little 11 that's just sort of hanging there as an arc length there. And so then the question becomes, that's 11, that's R is 12. I got theta on my hands. So divide through. And now I have this, but I need it in terms of theta. Theta now is in terms of radian measurement. So 11/12, what is that about? Or need some calculator out here. .92?
Yeah.
Okay. If I leave as many digits as you can past this here, maybe 4 digits or so, 5.
It's 9166666.
Okay, got it. Okay, we're going to convert this into radian measurement. Go to degree measurement. So multiply by 180, divide by pi. And what is that?
52.5 degrees. Rounded.
That's cool. Okay, I think I got what I need here now. So 50, 55.2 or 52.5?
52.5.
Cool. Okay. Think I'm getting closer. So once I have this angle, I think I should be able to find this guy now. What would that be? Sure, it's the D angle.
Minus 52.5.
Say that again?
Wait, minus 31. Oh, yeah.
Yeah, minus 31, the other angle.
96.
96.5 is good by me. Okay, awesome. So that's 96.5. We have still some other trouble here because this whole side is not just a number. It's actually the radius plus the x value. That's okay. Let's work with it. So I'm going to go with sine of 96.5 degrees over. That other side is now what? X plus 12. Are you okay with that? Over, let's see what side that we know. We always need a angle and its opposite side, at least one of them here. So I got 31 degrees, or sine of 31 degrees over 12. This time, just a little more complicated. We're solving for x. So how about multiply through by 12 over here? So this is sine 12 over 96.5 is equal to, whoa, this will be fun. It's going to be x plus 12 times sine of 31 degrees. Could I just divide by sine of 31 degrees? Just move it over to the other side so I don't have to distribute stuff and then undistributed. That's cool, that's gone. So then I guess it's that subtract 12. So 12 sine of 96.5 degrees over sine of 31 degrees, subtract 12 should give us x. Try it on your calculator, see what happens. As you guys are trying to test back. We have time to do test corrections here. So test corrections, let's see, on a separate sheet of paper. Give me a sentence of what you understand you did wrong as well, right? And I got the little correction sentence and then the work underneath it. Okay, answer.
11.15.
Okay, that sounds good to me.
Yes.
Yeah. Good. Okay. 21 done. All right, 29, the next one, you guys tell me if I'm going too fast. 7.129. I have angle of elevation. The mountain is here, da-da-da. And then the tower is sticking like this. So we know that this is a 110-foot tower. We have a person standing here. Here's Stickman, da-da-da-da. Okay, let's draw Stickman a little bit better. Give him eyes and a happy face. He's happy today. Okay. It's notice that a 100% tower subtends an angle of 1.5 degrees. Okay, let's go with it here. So fun part, now that we know the law of sines, we could get height or distance of something just from one vantage point only. We don't have to get 2 points now because of it. So what we do is we go to the top here, just this little piece alone right here is 1.5 degrees. And then we also know that technically it should be discounting the stickman's height. If we just go like this right here, this would be 25 degrees. Yeah, I drew it a bit wrong here, but.
So
Stick-
there's technically two triangles.
So this is 25 degrees here. This is an extra 1.5 degrees over here. We know the tower is 10. Find the height of the hill. And Stickman should have been a lot smaller because we discount his height. Beginning of the year, remember we were doing the measurements around Sloka, right? We did have to account for height because they're small, but a mountain range, I don't think so. Okay, so we want to find out this whole piece right here. All right. Anybody?
Wait, so do we want to find the height with 110, or do we just want to find the height of the hill?
We want to find the height of the hill only. It says find the height of the hill. So this little H right here. Oh, thank you. It's just from here to here. Fun problems or frustrating problems? Which one for the homework? Both? A little frustrating-ish? Especially these.
Other people are having fun.
Don't find that out.
Yeah, it's not fun when I do.
Sorry, guys. Okay. See, loft sign, somehow I want to get an angle here. It's opposite side.
Just a wall.
For these loft signs, we almost like get an intermediate sort of step that we know. And so let's see if we can find that.
Do you solve for the angle, like right above H?
We could probably do that. Yeah, let's put in everything we know. How about that? Let's put in everything we know. So that will angle there. What would that be?
63.5.
Say again?
63.5.
How come is, Adrian?
So why is it 63.5?
Uh-huh.
Because of like funny triangle math.
Because of math.
Because of math, yeah. Yeah, okay. 90-degree angle here, so that we only have an extra 90 to spare for a triangle. These added together, subtract from 90 gives us that, or the complementary angle to 25 plus 1.5. Okay, so it looks like if I'm going to do the law of sines, I'm thinking that this little piece right, I'm just going to call it x. We're good. I have a relationship to x somehow. That could be it. Okay. So off to the side, I'm just going to put what I know to be true here. Sine of 63.5 over x is equal to, and that might go somewhere, it may not. We'll see. Okay, this whole piece is 26.5. All right. I'm assuming this would have to be it, just like we did the previous problem. There was a connection to it. Let me jot down some other stuff we know. How about this? We know that opposite over adjacent. Would that be tangent? Let me just check something out here. So this would be tangent of 25 degrees is equal to opposite over adjacent. Does that help us any? I'm stuckies. Let's see, I'm gonna try this one as well, yeah. So that's this little piece right here, right? That's just the X value.
The way I did it is I found X as being the line, I don't know how to describe it, like opposite, the other side, not H, not 110, and not X you've drawn.
This piece right
but,
here?
The one above it.
Ah, this guy here, all the way on top.
Yeah, and so I solved for that by doing the sine theorem with just the triangle, with the 1.5 degree, the 63.5 degree, and then I found that little angle inside there.
Gotcha. So this little triangle right here.
Mhm.
Okay. Let's take Amea's way of doing it. Let's go for it. Let's try. So I have 1.5 degrees here. I know this to be 110. And Amea, I think that's pretty good. Okay, 63.5, is that right? So that means we could find this angle as well now. That'll be 180 minus 1.5 minus 63.5, which is?
115.
I like that. That works. Now the law of sines can come out here. Let's see. Sine of 1.5 degrees over 110. And sine of 115 over, let's just say X. On 110, sine of 115 degrees. Okay. Talk to me. Anybody have that answer? We're gonna just check Amea's work here. May, what'd you get first?
I got 3,808 and then 0.46.
Okay. Someone check just to make sure. Awesome. Okay. That's cool. Okay. On this side now that we have this piece, I think this is what you did, right? Now it's sine of 26.5. Now you have yourself a right triangle. Now you can work with that. So this is sine of opposite, which is over hypotenuse.
Yeah, the way I did it was I just used the law of sines again.
Okay. 90 degrees, using 90 as the other one?
Yeah.
Gotcha. Okay. That way we can go, if you want to do Amea's way, then it's that equal to, still had to do it this way, right? Still had to put in, oh, you know, let's check this out because this is interesting. You're going to put the sine of 26.5 over 110 plus h. Are we good? When you do that, what is sine of 90 degrees? It's just 1 anyways, right? So if we were to flip this over, it technically becomes, or actually multiply this guy over here, right? It becomes the same exact thing. Okay, so what do we need to do? We need to go 3,808.46 times sine of 26.5 is equal to all that. So we've got to subtract that out. So now it's 3,808.46 multiplied by sine of 26.5, then subtract out 110. What do we get for h? I mean, what did you get first?
I got 1,589 feet, and then in the book they rounded it to 1,600 feet.
Gotcha. Cool. All right, try that on calculator just to make sure you get it as well. Cool. And
Wait, you said 15.
at that point, it's a matter of significant digits, so it's whichever is fine. As long as you know you're close, as long as you did it right, you're fine. Okay. Thank you. Okay, 7.1, number 33. Let's jam with that. Ship is anchored off of a long straight shoreline that runs north-south from 2 observation points, 18 miles away from shore. The bearing of the ship is, okay, got to get my compass out. North-south, west-east. So the shoreline has to be on this side.
For some reason, whenever I come to a compass problem, I'm just like,
Yeah,
I can't do this.
I'm like north, south, what now?
It freaks me out. The northeast.
And then I was like, wait, you
southwest,
can
and
only
like-
go from north first. So it starts at north and then it goes 30 degrees east. And I'm like, but how can it be 2 places at once?
Straight shoreline that runs north-south with 2 observation points. Okay, these guys are 18 miles apart. Okay, 18 miles apart from each other. The bearing of the ship is north 31 east, so it has to be from this guy. This is to the ship is looking north, subtending it. And you know what, let me erase this now. Subtending it, oh, make up time. 31 degrees this way. This one's going to go south. So going south and then extending it to the east side, this is going to be 53 degrees now. And that's all we need to know. We should be able to find out how long the distance is. Where's this used at? Besides that is forest fires, where you have different towers. They're away from each other. We know the distance between towers, right? So when a fire starts, they do look at degrees. They know exactly the pinpoint of where that fire is, which is kind of cool. Let's see, GPS systems work exactly the same way. As long as you know 2 GPS systems, you have a 2-dimensional view of the landscape. You have that. The cool thing is on certain apps, I'm not sure if you guys have any like bike apps that you have, they're using 3 points now. So if you go up a hill, you burn more calories than just walking straight, right? So they got to the point of actually GPS for walking or bicycle apps. They see a 3-dimensional view of you. And so they'll know just an elevation change as well. And they'll tell you how much calories you're burning. Why? Because they have a 3-dimensional view, which is interesting. Freaky, interesting though. Okay, let's go with the law of sines. Give me this angle right here.
Wait, so what are we trying to solve?
I don't know. What is the distance from the ship to each of the observation points? They're just making you do more work right now.
Like that.
So good. Looks like I need 180 minus 53, and I'll just put minus 31. Awesome, 96 degrees. And let's just do one of them, right? Because this is just law of sines. I think once you got it, the rest of the work is just really set. So sine of 96 degrees over 18 equal to all these interesting questions that come up. Let's see, I'm going to go with 31 over, and I'm going to label these here. I'm going to label this one as A, this one's B. So A. All right, see if you guys knew this in your head as well. So if A's down here, right? It's going to multiply across. I'm going to get 18 over here where the numbers are. 18 sine of 31 degrees. I'm going to divide through by sine of 96 degrees. Say again?
9.3, yeah.
9.3?
Yeah.
Cool, okay. So from tower 2 to the ship is 9.3 miles. Cool. And the other one works the same way. And have those set up.
So then when we do the other one, do you think we should still use the 18 since we like know that that one's 18?
Sure, yeah, Now, we talk about in science that if you want to use the ones that you were given. Those are direct measurements. We go from there. And beyond that, in science, if you have a tool that can measure better, right? And if you have that one as the measuring tool, then you would use that to give you less error. Okay, we're jamming. (7.1), number 37. Sorry, give me the answer for this one. B.
14.
Ooh, okay. Yeah, it was closer up there. And here's the answer to B. Okay, and we have the force stuff. Cool. And it has a chairlift here. We have 2 towers. Some kind of cable. And we have people stuck on a chairlift right there. Hopefully they don't die. 71.8 and 74.8.
Hopefully they don't die.
Hopefully.
Good, this is a math problem, and not something that's actually happening.
That's a new experience.
In which one's, I think it's Arizona, Albuquerque, New Mexico. There is the second largest, is it a cable car? It would be a cable car. They go from one, it's not a cable, is that considered a cable car? I guess it is, right?
Yeah, like the gondola.
Oh, yeah. So it's the second largest one, but it holds the record for being the longest distance between 2 poles. So you got this gorge that you're underneath, and you got this thing that goes back and forth. And the somewhat scary idea is that when you're on top, they don't release you because it's too windy. And you keep on waiting, sometimes like 5, 7, 10 minutes. Like, okay, now you can go. And so I'm not sure if that's, oh, I don't know.
Do it.
And then, but it's cool going between the two posts, right? Because they're just so far apart from each other. And you got this big gorge, and it's just going, and you are swaying back and forth as it's going. And sometimes it stops because it's too windy, and you just got back and forth, and then it continues on, and you keep on going. So if you ever want that thrill, now you know where to go.
Actually, Albuquerque would be so much fun for
Seniors.
Oh my gosh. Oh my gosh. It's so crazy.
Yeah, it's the best idea. Burning Man.
I think I can tell about the right.
Yeah, I think that really is.
Okay. Okay, it's 1,850 pounds. That's what it says. So you have a force going this way. So we know that the cable has not snapped, and so the cable car, the chairlift is still in one, is stationary. So now the question is, can we rebuild this in terms of a triangle? So first things first, probably this one's the easiest one to do. This one, we go like this. This is magnitude, right? So this is 1850. It's just going down. And we should at least, let's see. If we want to, notice if we were to slide this back up, if we were to slide this back up over here, we would get this little line right here. This line goes all the way down, right? So we can take this little piece right here, that one, let's slide that over. That should go this way for us. Okay, and then the angle, talk to me, can we keep that angle? Yeah, that angle is kept, right? Because it's the downward. This is 74.8. That's cool. So now we need this last one here. It comes over here. So now I'm going to put this one in. This is the last force.
Does that say 185 degrees or does it
No,
say
no. 1850. Okay, this one is a bit of a tough one here. So this is 71.8 degrees on this side, right? But notice it's with the vertical line. So if anything, we put another vertical line this way. And this little angle is hanging out right here. So now talk to me here. How do we figure out this inside angle? That's what I want.
You can just put that angle inside the triangle because of the, it's like two parallel lines and then one straight line. I think that those two are the same, right?
Ah, got it good. 74.8? This one?
No, the 71.8, you can put that on,
Oh, yes, yes. So if you talk about this guy, remember geometry class? Don't remember all of geometry class.
I like how you
Just-
answered your question, Nancy. Do you remember? No.
You should have learned it by now that we don't.
Right. I learned.
No,
71.8 goes in here. Right, that was the parallel lines and a transversal cutting across. That's cool. Okay. I was going to go the long way because this one's also 74.8 right over here. And then you subtract it from 180 to get there. But that's the shorter way. Okay, now I need this little angle right here. I need this one right here now. And let me get rid of my alarm because my alarm keeps on going off. Okay, that should be it. Thank you. All right, 33.4 degrees is this angle right there. We good there? Let me draw it out a little better. Let me get rid of stuff. Way better. 33.4. Okay, law of sines. How can we put this in? What are we trying to find?
Just what we don't know. So the
And the magnitude
tension
of
on
the tension.
CA and CB.
Gotcha. Mhm.
Yeah.
So both sides, just like the other problem here. So sine of 33.4 degrees over 1,850 is equal to, and then let's just go each one of those here, 74.8 over, and we got to label these guys. Let's see, this would be little a coming across here, right? So this is little a here. That's angle B. Now we've moved it over, right? So this would be little b. We moved it on top of the triangle now. So that would be B. And the other works the same way. In your mind, cross multiply these guys. And then divide through by the other sign. If you can do it in one step, and that should be equal to B. All right, punch it in. Let's just do one of them. Good there? And that would be in terms of pounds at that point. So, no wonder we need metal cords to put that together. That's a lot of poundage. Okay, are we good there? The other one you just do solve for A, but very similar. Okay. Did we do all of 7.1? We did, huh? Let's do this here. Time remaining. One of those here we'll do on Wednesday. I do want to show you a couple of things from 7.2 because we did not finish 7.2 yet. So let's jump at it here. The lecture part of the class in the last 5 minutes of class.
Yeah, I can just show 31. Because I labeled them X and Y when I did it on accident instead of A and B.
All right, let's see. Now I do it this way. I think this is the one we did. We were here somewhere, is that right? Did we go? We went through this right here as well, right?
Yes.
The different cases. All right, we finished up right here, I believe. Or we almost finished up right there. We're on example 5. And what we did is we figured out each of the B values. Whew. Thank you. Now I can exit it. Okay. All right. Let's see if we can kind of, let's see. Did we finish this one up? Example 5. Finish up one triangle, the other one here. They want to show you the navigation pieces here. Of it here. Talk to me. Example 5 done? I hear it out. Okay. Okay. Let's jam with this one here. So this is example, okay. Went from example 5 to 8. Math teachers still learning how to count.
Well, you went from example 7 to example 5.
Oh, okay. Then we're good then. Never mind. Then we go back to this.
You know why you did that?
So
I have
technically
no
it's
idea.
example 5, yes. I was gonna say, I was like, wait, what?
Just to confuse Matthias. That's primarily the reason. So let's go with drawing vectors and then a navigation problem here. And then let's see if we can get to the other little piece here too. So draw a vector representing the course of a ship traveling 80 miles on a course with heading 135. Notice from the homework from 7.1, we're not given directions of north and east or south and east. It's just 135 degrees only. Done. Makes it a little bit easier. Then you're just dealing with numbers. You don't have to put the letters in there. And so in this case, I just kind of put in the navigation. The heading of an object of an angle measured clockwise from due north is technically the vector drawings. So if we think about due north, and now we have 360 degrees that we can use. And so if you're gonna draw a ship traveling 80 miles on a course with heading 135, let's see, 180 degrees would be directly due south. We're not directly due south, we're about right here. So right there, there's your 135 degrees and done. Are we good? This is the simplest way we've learned how to at least do headings right there. Just straight off due north, now it's just a number. Say again. That's it. We're just drawing it and done. And normally what we do is we do put in the 80 because it tells you how
Oh,
fast
wait, you're
to go.
adopting it.
Say again.
Wait, that's actually it.
That's it.
Oh, I thought you
Well, now we have the problem afterwards. That was just the
were.
setup.
Wait, so, oh, you're right.
Okay, are we good there though? Just the drawing of it.
I'm so good. Once they
If
get
you could
there.
just stay
Uh-huh.
here, yeah.
Yeah, I
Leave
agree.
it on the floor, just let it work its
So you
way out.
don't die. You can-
Sorry guys, can't stay there. Gotta put you on.
You think you're supposed to teach us stuff here, and it's like, I don't,
Who told you that?
Right.
Yeah.
Okay, now can you draw two vectors like this?
Truck is gonna burn in there in the later, so.
So I'm gonna still signify due north, just like this. And then let's see, plane flying at airspeed 170 miles per hour and is heading 52.5. And this is kind of weird. Its true course is technically 64.1
Oh,
from due north. And then we've got to figure out stuff.
So when it says true course, what does that?
Yeah, that is so weird. Okay, so with airplanes and with ships, right? Because we have currents in the air, and we've come to the place we can actually finally do this here. You have a ship that would be going this way, drawn as a vector, and you also have wind currents or even sea currents, right? That's pushing this. Maybe like this right here. This is the wind sort of hitting the boat, right? So what happens is, if I were to draw this wind current down here, so then the true route the ship is going is right there. So the fun part at sea is that you can't, if you want to get somewhere, you don't point toward that direction. You've got to compensate for wind currents, water currents. In a miniature scale?
It's doing that on purpose. It's not, it didn't make a mistake.
And so what airplanes do, what ships do, is that they plot a course this way, understanding that the wind currents and the air currents going to take you a slightly different direction. In airplanes, though, we do use a compass, so that helps because then you're staying on this course, right? If you need to turn a little bit left in order for the compass to be lined up. So if you're going 33.3 degrees northeast, you just keep that direction by the compass. Okay, let's see. We have a little bit of time just to get started here. Let me set it up here. So we have an airplane flying airspeed of 170 miles per hour, and we have that vector from true north, 52.5, and we usually label this as 170, just on the line itself. Its true course, however, is 64.1 degrees from true north. So then we have this one. This is, let me change pin color. Here's your true course. This is what's really happening. And the angle measurement that's happening is 64.1 degrees. Okay. Then it says if the wind currents are constant, 40 miles per hour, what's the possibilities of the ground speed? That's weird. Okay, so hold on. We know that the wind is pushing this way for sure, right? It's pushing that way down.
Wait, so the whole angle is 64.1.
Yeah, the whole angle, all the way from true north down. Hey, you know what? Doesn't this look like the ambiguous case? Like if I did this is 170. What's the angle in between there? 64.1 subtract the 52.5.
11.6.
See?
11.6.
Thank you. And then I have this little piece right here. I know this has to be 40. So can you guys compute? That is the ambiguous case right there.
Yes.
No, definitely do that.
There it is. There. Is that better?
Oh, yeah, but is it just one half? Oh, I guess that was the wrong.
11.6 right
The
here.
bottom's like cut off, but
Where?
no, it just looks like the bottom half's cut off, but I'm just stupid. And I thought there was one in the triangle, but
Okay.
there's not. Never mind, we're good.
Oh, yeah, true.
Let's label this here. Let's say this is B would be 170 or H, sorry, H. Remember that H is what we need to get across here. 170 sine of 11.6 degrees. What's that value? How much do we need to get across?
34.18, so 34.
34? Oh, cool. Okay, so 40 is enough to get us across the minimum. Oh man, that means we have one possibility going this way. So it could be that the winds were actually hitting that way. Or it could be that the winds were hitting this way at 40 miles an hour. We're good. We got to find both of them. Oh, okay. Let's at least set it up here. So I have one possibility before time expires here. Like this. This is 11.6 degrees. This is still 170. This is 40. Then the other possibility is the winds were actually coming this way at it. So this is still 11.6, that's still 170, and that's still 40. And I'm going to do this here just. In fact, let me stop here. Your homework is to finish up this problem. We're good? We can figure out this angle right here real quick here. The setup would be sine of 11.6 degrees over 40 is equal to sine of, I guess we got to label these A, B, C. This would be sine of B over 170 multiplied by 170 equal to sine of B. And then in your calculator, if you have it, punch in that right there. What do we get? Nearest 10th, I guess. Yeah, the other one's nearest 10th. And make sure you're in degree mode. That's kind of helpful. I got maybe like 58.7-ish.
Yeah, that's what I got.
Okay, so that B value is 58.7. So then real quick here, how do we compute? Oh, we got to label this as A prime, B prime, and C prime. How do we compute B prime? Gotcha. It would be 180 minus 58.7. It would be the supplementary angle to that one.
Wait, B would?
B prime, the second angle, the second triangle that we have. I'm gonna stop there. We're over time. I'll explain that and we'll finish off this problem on Wednesday. I'm gonna hold off on the homework of 7.2 being due on Wednesday as well. Absolutely, and have a good day.